Hello and welcome to Day 3 Notes, the second day of multiplying matrices. As promised, today we're going to do some word problems as well as look at some maybe a little bit unusual cases of multiplying matrices. Okay, for example 1, it says for their 1-week vacation, the Miller family can rent a 2-bedroom condo for $1,796, a 3-bedroom condo for $2,165, or a 4-bedroom condo for $2,538. The table shows the number of units at each resort. So notice our rows here. We have Sunhaven, Surfside, and Seabreeze, and then across the top we have our columns, which are the 2-bedroom, 3-bedroom, and 4-bedroom. So basically, if you were to interpret what this means, Sunhaven, for example, has 36 2-bedroom units, Surfside has 32 3-bedroom, and so on. So that's how you would interpret this data. Okay, so for the first part of this problem, part A, we want to write a matrix that represents the number of each type of condo available at each resort. So just like the word problems before where we didn't really do much with them, we're just going to take this and rewrite it. So our first row is Sunhaven, then Surfside, then Seabreeze. All sound lovely. Okay, then we have 2 bedrooms, 3-bedroom, and our 4-bedroom units. Go ahead and write the numbers. So 36 2-bedroom, 24 3-bedroom, 22 4-bedroom at Sunhaven. Surfside has 29 2-bedroom units, 32 3-bedroom, 42 4-bedroom. And Seabreeze has 18, 22, and 18. Okay, for the second part of this, we want to write a matrix that represents the weekly charge for each type of unit. So in the description of this problem, they told me the 3 various prices. So the first one is $1,796 for the 2-bedroom. Then we have $2,165 for a 3-bedroom and $2,538 for a 4-bedroom. Now you might be asking yourself, Self, how do I know that this has to be a row matrix? How do I not know it's a column matrix? So for now, we don't really know until we look at the follow-up question, so I'm going to write it as a column matrix as well. Okay, so again, as far as sizes, this is a 1x3 and this is a 3x1. And that's going to become important for later follow-up questions, especially the one that's coming up next. So for C, it says if all the units in the 3 resorts are rented for the week, express the income of each of the 3 resorts as a matrix. So I'm going to begin by rewriting my 3x3 matrix from part A. It was 36, 24, 22, 29, 32, 42, 18, 22, and 18. Now for these word problems, the trickiest part is to figure out that second matrix, how to multiply it so that the answer that you get makes sense for what the question is asking you. Therefore, it becomes important to label your columns and your rows so you could keep track of what you're multiplying where. So we're going to do 2-bedroom, 3-bedroom, 4-bedroom, then we're going to do the Sunhaven, Surfside, and Seabreeze. So remember part B, I said I don't know which type of matrix it is. Is it a 1x3 or a 3x1? So here's where it becomes really important to keep track of what order you're multiplying in. So let's say I took the first one I wrote, my row matrix. Because it's a 1x3, the only place that I could put it to multiply this 3x3 matrix with it is in front of it, because then the 2 inside numbers, if this is a, again, up here, this is a 1x3, the one I just drew is a 3x3, these numbers have to match, so I would have to put that in front. So let's say I did. And I would have 1796, 2165, and 2538. Okay, again, this is a 2-bedroom, 3-bedroom, 4-bedroom cost. The way we multiply matrices is you take the row times the column. So let's think what we would be doing here if we were multiplying these values. I would take the cost of a 2 and multiply it by the number of 2 bedrooms at Sunhaven. Okay, sounds good. Then I would be taking the cost of a 3-bedroom condo, and wait a minute, I'd be multiplying it by the number of 2 bedrooms at Surfside? No, that doesn't make sense. So therefore, when you label it, you see what you're multiplying, and that, again, makes no sense. And if I kept going, a 4-bedroom cost by the number of 2 bedrooms at Seaside, not good at all. Let's see if we did it the other way. Okay, so I'm going to just cross this out because that was no good. Let's write it now, that same, not the same matrix, but let's try the 3 by 1. So now I'm going to have my 3 by 3 times this column matrix here, 3 by 1. So let's put those prices there. 1796, 2165, 2538. So now when I label it, this is my 2-bedroom, 3-bedroom, and 4-bedroom. So matrix multiplication goes rows by columns. So it would be this row times this column 3 times. Now let's see if this answer would make sense. I would be taking the first value in the row, 36, the number of 2 bedrooms at Sun Haven, times the cost. The first number in the column is the cost of a 2-bedroom. So far, so good. Then I would be doing the 3-bedroom times the cost of a 3-bedroom, and finally the number of 4-bedroom units times the cost of a 4-bedroom unit. Sounds good to me. Let's see if it works for the second row. So for the second row, the first number I would be multiplying is 29, and I'd be multiplying by the cost of a 2-bedroom unit, and 29 is the number of 2-bedroom units. Then I would be taking the number of 3-bedroom units, multiplying it by the cost of 3-bedroom units, and finally I would do the number of 4-bedroom units at Surfside times the cost of a 4-bedroom unit. So hopefully you see that this makes a lot more sense than when I put that row matrix in front. Those numbers, when I was multiplying them, they didn't really have much to do with each other. So you kind of have to, with these word problems, you do have to play around a little bit. It's not always so cut and dry that you know which way it needs to go. You sometimes do have to, put one in front, see what would I be multiplying here. Then if it doesn't work, put it in back. You do have to play around with it, unfortunately. So, okay, I'm going to go ahead and multiply these two matrices. So first row, 36, 24, 22 times this column, 1,796, 2,165, 2,538. Okay, 36 times 1,796 is 64,656. So that's the amount of money that Sun Haven's going to make on just the 2-bedroom units. Plus, if they sell out all of the 3 bedrooms, we're going to do 24 times 2,165, and that's 51,960. Plus, now the 4-bedroom units, 55,836. All right, I'm going to do second row, which is going to give me the values for Surfside, and those are 52,084. Makes sense that it's less than the previous resort because they have fewer units. Plus, now this number should be bigger because they have 32 3-bedrooms. Let's see, 69,280 plus 106,596. Yeah, they got a lot of those 4-bedroom units there. Okay, last resort, Seabreeze is going to get 32,328 from the 2-bedroom plus 47,630 from the 3-bedroom plus 45,684 from the 4 units, bedroom units. So now we want to know the income of each one. This is not really showing me how much it would be. So I'm going to add those up and find out how much they would make. So Sun Haven is going to make $172,452 per week. Surfside is going to make $227,960 per week. And Seabreeze will make $125,642 per week. Okay, so part D then asks us what is the total income of all the resorts for the week. I'm just going to take these 3 amounts that I found in this matrix for part C, and I'm going to add up those values. And I get $2,576,054 for the week. Okay, so example 2 and example 3 are matrices that I have found in the past give students a tough time because you don't really expect the answer to look how it ends up looking at the end. So let's go ahead and practice this. The first one we have is a column matrix times a little row matrix. So first let's see if the product is defined. My first matrix here is a 3 by 1, And the second one is a 1 by 2. So again, we look at these inside numbers. They are the same. So the outside numbers gives me the dimensions of my product matrix. So my matrix is going to be 3 by 2. So it's going to have 1, 2, 3 rows, 1, 2 columns. So I'm going to fill in the second column. All right, so again, matrix multiplication is rows times columns. So my first row is 4. My first column is 1. 4 times 1, 4. Now because the row ends and the column ends, there's nothing else that goes there. So now I'm going to do row times first column, second column I mean, so negative 12, and I'm done. I'm done with the first row of that. So moving on now, I'm going to do second row. So it's 5 times 1 is 5, and then 5 times negative 3 is negative 15. And the last row, first column is going to give me 6, and then last row, last column gives me negative 18. So if these little slashes bother you, if these little blank spaces bother you, rewrite it. It bothers me, so I will rewrite them every time. That's my product matrix. So again, when you start off, you don't expect the answer to look like that, and it gets kind of confusing when you're not adding more things to each entry. Okay, so example 3, I want you to stop the video, try it on your own, and then compare your answer to mine. And if you have any questions, please, please, please make sure to ask in class tomorrow. Okay, so you should have gotten a 1 by 1 matrix that is just negative 3. For this last part of the notes, I'm going to show you how to enter a matrix into your calculator. For the rest of this chapter, after today, after the quiz actually, so when we get back from break, everything we do is going to be strictly on the calculator until we take the quest on that Friday before finals week. So please get your calculator. If you don't have it, pause the video, make sure you go and get it. So I'm going to be entering this matrix into my calculator. I've provided a picture of a TI-84, so hopefully that'll make it a little bit easier to follow along. Let's go through the steps of entering a matrix into your calculator. I'm going to go slow, so you could be doing this as I'm doing it, so that tomorrow if you have any questions, please make sure to ask your teacher. To enter a matrix, to access the matrix menu, you want to press second x to the negative 1. The x to the negative 1 button is located right here if you look at the picture of the TI-84. And that brings up the matrix menu. Now, because we want to enter a matrix, you scroll twice to the right to edit. You're going to be putting in the matrix that you want to put in. The first thing that you're going to be asked is the dimensions of the matrix up here. It asks you how many rows does it have, how many columns does it have. So ours is a 2 by 2 matrix, so you will press that, hitting enter between each number. And once you do that, it will take you inside the matrix where you're going to enter the elements of it. So ours is 3, then you hit enter. Negative 2, enter. Negative 1, enter. 1, enter. So now you're still inside of your matrix. So to get out of there, you have to press on your calculator second quit, and quit is right here next to the second button. That brings you to your home screen, your blank screen where you do your calculations normally. And now we can access that matrix by pressing second x to the negative 1. If I want to use the matrix, looking back up here to this menu, notice that the first thing here was names, and that's where you should automatically go if you just press second matrix. We want to use matrix A. That's our first matrix. That's the matrix that we entered. So you press enter. When you do press enter, a matrix with a capital A inside of it shows up on your screen. I decided to multiply mine by a scalar of 2, giving me the result when I press enter, 6, negative 4, negative 2, 2. In the future, we won't be just entering one matrix because we're usually going to be doing things between two matrices. So if I wanted to then enter a second one, I'm going to follow those exact same steps, except I'm not going to call it matrix A twice. I'm going to call it matrix B. And then enter its dimensions, enter its elements. Okay, so we'll be using that in the future. Make sure you do know how to do it and that you understand how to enter a matrix. And if not, ask your teacher. All right, thanks for watching. Have a great one. Bye.